Hello everyone, I am Mohammad Khalid and welcome to my YouTube channel Physic-so-Mathematica Techno-Computa. So in this video I am going to solve the coding ninja problem, and it's a problem of the day problem and it's a hard type problem. So the problem goes like this: you are given a matrix a mat of n rows and m columns. Your task is to return the zigzag order of the matrix. So let's say they have given 5 cross 5 matrix. So whatever the element present here, we have to return first. After this, you have to return element present at this location. So in the zigzag manner we have to go in this like. So in this way we have to return the elements. So let us take this example and see what they're saying. This is basically 3 cross 3 matrix, and then elements are 1 2 3 4 5 6 7 8 9. So basically they are given matrix of 3 cross 3 where n and m both are 3. So elements are like this: 4 5 6 7 8 and then 9. So now the thing is, we have to return in zigzag format. So first we have to start like this, and then we have to go left bottom, and then we have to go down, and then we have to go upright, similarly upright, and then we have to go down, and then we have to go left bottom, and then we have to go left element. So if you go in this way, zigzag manner, so we'll be encountering element as first 1, and then we'll be encountering 2, and then 4, and then 7, and then 5, and then 3, and then what is this, 8. No, sorry not 3, not 8. After 3 we'll get 6, and then 8, and then 9. So basically, as you can see, 1 2 4 7 5, 1 2 4 7 5, 3 6 8 9, 3 6 8 9. So in this way we have to return. So if you keenly see in this zigzag returning array, we will find that basically first we are going right side up, and then we have to turn, and then we are moving to left side down. So this is basic idea. So first our idea will be, we will move to the right side up. So let me take in a fresh 1 2 3 4 5 6 7 8 and then 9. So first we'll take a loop, and we'll put a while loop, and then in that condition we'll be putting as I star j, because in these cases I and j, they are continuously increasing, either increasing or decreasing, something like this. So we'll be taking it I cross j less than equal to n minus 1 star m minus 1. We'll taking in this form. So basically n minus 1 and m minus 1 indicate this position. So if this elements what we are encountering is less than this position, then we'll be moving into the loop. If like I cross j, which means this position, if we exceed this position, then we'll be simply coming out of the loop. So m minus 1. So first what we'll do is we'll write inside this loop while loop in such a way that this I should move right side up first. It should move right side up. If there are no elements on the right side, then we have to move left side. This way we'll do. Okay. So once we move left side, so we have to move downward. Sorry, not left side, right side. So we have to move downward left side in this case. So we'll be moving continuously downward, and then if we encounter there are no elements this side, then we'll move the cursor down. So we'll move like this, and then once we move down, we'll be continuously moving right side up, continuously moving right side up. So here also we'll move, but there are no elements here. So what we have to do is we have to just move down, and then only one step we have to move that, and then after moving one step down, we have to move left side down, and then there are no elements here left side down. So we'll simply we'll check here in this case, because in this case also we are moving down, but the thing, like left side down we are moving, so we couldn't find any element. So we have moved down. Second step was moving down. So here since there was element, so we move position to this location, and then we move upward right side. But here in this case there are no left side down elements, and also in down if we check there are no elements. So in this case we have to move right side. So finally we will be coming to we'll be moving this array in zigzag position. Let me take one more array of size, let's say 4. 1 2 3 4 cross 4 I'm taking, but the thing is in examples I'm taking n cross n, but whatever algorithm will be writing, it will be implied for n not equal to m also. 4 5 6 7. So 4 one more time I took, there's no problem, because elements given will be different. Here there may be like 10, some sort of 33, let's say. Here is some, we have 47, something like this. So 8 9 10 11 12 13 15. So let's say they have given this matrix, so we have to move in zigzag position. We have to find elements in zigzag position, and that elements we have to store in single one dimensional vector, and we have to return that vector. So basically first what we will be doing is we'll be moving first right up. So right up if we move, so since we don't have any elements here, so we'll move cursor to the left, and since we move cursor to the left we find an element, so immediately we'll move to the left bottom. So continuously we'll be going left bottom side, left bottom. So as we move continuously left bottom, since there are no elements here, so we'll move the cursor to the down, and if there are elements, like if there are elements in the down, so one element is good enough to find, like in down is there. So if it is there, then we have to move continuously to the right upside, continuously have to move right upside. Here also we'll move, but the thing is here we don't have element, so we have to move to the right. So since here element is there, so now continuously we have to move left down, down left we are moving, down left we are moving. So here also we are moving down left. So but the thing is here we don't have element, so we'll check down. Since we didn't here like we've checked left down, we don't have any element, so we move down. Here also we're checking left down, and also we're checking down side. Since we don't have any elements, so in this case we have to return right side. So and after returning right side, we have to move again upside right, upside right we are moving. Here also upside right we are moving. Since we don't have any element here, so in this case what we should check is, we used to check if upside element is there. If it was not there, so we used to move to the right. Since in right also we had element, but here if you move right we don't have any element, so in this case we have to return down again. Since we got element, so we have to move left, we have to move left down. In this case we'll move to the left down. So since there are no elements in left down, so we'll check if there is element in down. In down also we don't find, so we'll move to the left. So in this way our algorithm I'll be designing. So let me explain the algorithm first. Now we will take a loop while, and which will be running from I star j less than equals to n minus 1 star m minus 1. So this will be our while loop. So from this will running, and initially we'll take I and j element as 0, because we have to move from the first position of the matrix, and then we have to move in zigzag position. So we're doing this thing. And now, as I said, like we have to continuously move upward right side, and in order to distinguish between the motion upward right side and then downward left side, we'll take one variable known as flag. We'll take flag variable, and if flag is 1, then we are moving to the upward right side. Since from the starting only we have to move upward right side, so I will initialize here one variable called flag, and then this value I will be taking it as 1. As I said, like from starting only we will be moving right side up. So now I will be taking first we have to distinguish if we are moving upside or downside, like upside right side or down left side. So that is distinguished by the variable known as flag. So I will take flag, if flag, which means, so if flag will be 1, which means we have to move to the right upside. So in this case what I will be doing is I will be taking one more loop, and in that condition will be like see, as you can see here, so ij will be 0, 0 at the starting position. So if you want to go to this position, so what basically you have to do is you have to decrease one I, and then we have to increase one j. Okay, we have decreasing one I and we are increasing one j. So same thing I will be doing here, like I will be I starting will be having, so in this what I will do is I will make I is equal to -1, and I will check if this is greater than or equal to 0, because for I this is a 0 position, this is 1 position, this is second index, and this is third. So since this is the boundary case upside, so we have to check if I -1 what we are checking is greater than or equal to j, and what we'll be doing is we'll checking j. Like for j case, this is the 0 position, this is first position, this is second position, and this is third position. We'll be checking like if j, since we are decreasing I and increasing j, we'll be checking in this case if j is less than equal to less than n. Basically in a program they have given like n as row and m as column, so m will be checking in this case, j is less than m. So if this will be the case, then we have to take one single dimensional vector, and we have to put that element in a vector we'll put, and then we'll decrease I, and then we'll increase j. Basically what we're doing is, like, let's say we are here, so we are checking if this element is there or not. So we are decreasing I and increasing j. So if it is there, we have to put this element into our single dimensional vector, and we have to go to this position. The same way here we will be having like we are at this position, and we'll decrease I and increase j. We'll check if this at this position we have element or not. Since we have element at this position, this 5 will be putting in our single dimensional array, and then our pointer will be here, like I and j position will be here. This thing will be doing, and then once we come out of the roof, like once we encounter, like let's say this we encounter here, so in this case since I is less than 0, so our I should be greater than or equal to 0, so this will be the terminating case. So in this case we have to check right side. So right side checking means I will be same thing, but j will be increasing. We will be checking j if here we have element or no. Okay, for this thing what we will be doing is, so we'll check if there are j or no. So for that we will be doing is if if j plus 1, and this should be of course less than m, because let's say here we have, okay, so first in while condition this unsatisfied, and then we're checking left side, sorry right side also we don't have element, since this is n minus 1, and this if condition will fail, not n, m minus 1, so this condition will fail. So in that case we have to move downward, so in that will be the else case. Now for this case j plus 1, since we have element, so we have to simply increase the j pointer, j plus plus, and since we increase the pointer, and also now it indicates as right side up movement is finished, now we have to go to the left bottom, so we have to make flag variable as 0, since 0 indicates we have to move left side down, and before this whatever the element was there, we have to add that element to a single dimensional vector here. And in else means this case, this is the case, like we don't have element to the right side, so we have to move down. Moving down basically indicates like we have to increasing the I position, so else like we have increasing the I position. And then this case also, if we move, once we move down, we are now we are moving to the left bottom side, so we have to make flag variable as 0. This was the case of upward movement, upward right side. Now left side movement will be same, like if flag variable is 1, we are moving upside. Now if flag variable is 0, so for that else will be there. So in this also will check while. So while what we will check is, since for downward movement, since we will be moving downward, so for that case we will be checking if I, let's say from here we are moving, so since we are, let's say we are at this position, so we have to increase I, and then we have to decrease A in order to go to this position. So same thing I will be doing, I will be increasing I, and this I increment should be less than n, and we have to decrease j minus 1, and this should be greater than equals to j. So basically I'll explain one more time. Let's say we are here, so we'll increase I and decrease j, we'll check if element is there or no, and till where we have to increase is, we have to check like we are going, and at this position we came. So now if we will try to increase, let's say I, so this will exceed the n minus 1. So if this is the case, we are coming out of the loop. So now if this is the case, we have to increase I and we have to decrease j. And now let's say we came here, this case let's take, we came here. Now we'll check if this in that loop we have I plus 1, we have element, but the thing is if we increase j, we don't have any element here. So for that case we have to again check for the down case we have to check, since the element is present down. So now going down will be like basically we are increasing only I, so we will be checking here if I plus 1 is less than n, then we will be simply increasing I, and then we will set the flag variable to 1, because since we came down, after coming down, this is the turning point, so we have to move upward right side, and so upward right side indicates flag 1, that is the reason I am taking 1. And one more case is like, since let's say we are here, we'll find first in while loop this thing, we have element or not. Since we don't have element here, so we'll be checking in if condition, like if I plus 1 is less than n, so this condition also fails. So if this is the case, we have to check the right side element we have or no. So for right side checking, since we are at this position, we have to simply increase j. I will be same because this is the same row, so we will have to check if j plus 1 is less than m. So basically we will include in the else part only. So else we will be doing j plus plus and then flag. So basically this is our algorithm. So and also here we will be taking the element and putting into the single dimensional vector. Same thing we will be doing here, and same thing we will be doing here. So and at last we have to return the vector. Let's say we have a vector named answer, so this we have to return. So let me write the code. So first we have to take one dimensional vector. Since we have to return one dimensional vector, we have to return the zigzag sequence. So let us take vector of int type, and let its name be answer and its size be n star m. Okay, so this is basically an n star m, so 9. So there will be 9 elements, all 9 elements you have to return, as you can see. So and now we have to take one variable I is equal to 0 for row, and we'll take variable j for column, and we'll take variable k. The reason why taking variable k is whatever we encounter the elements, we have to put in this, and we have to increase k to the next position. So we're taking it, and we'll take one variable flag, and first we initialize to 1 because first we have to move to the right top, and now we have to check I star j less than equals to n minus 1 star m minus 1, and we'll check if we have to move right top or left bottom. So if flag, and we have to check here if since we'll be moving to right top now, this is the case here. Since we'll be moving right top, so I minus 1 and j plus 1 will be checking. We'll checking I minus 1 if it is greater than equals to 0, and j plus 1 less than m. If this is the case, first we have to store the element. We have to store in answer of k equals to matrix of I and j. Since initially we had like I and j 0, so first element this will be storing in this position, and then now we are increasing, changing the position of I and j. So in this case basically this will be the position. So what we are doing is we are decreasing I and increasing j. So the pointer will be moving upward, like this will be moving right top. So once we don't find any element here, we have to move left. For that we have to check if any element are there right side, like this. We have to check any element are there right side. So that will be the case like j less than m. If it is there, then we have to increase j. Since we were here, we have to increase j, and then we have to put a flag variable to 0 because basically we have to now move downward left side. So if this is the case, and one more case is like we don't have any element here, and we don't have element at the right side also. So now we have to move down. So moving down is basically we have to increase I plus plus, and then flag variable we have to put 0 because after this also we are moving left bottom side. So this is the case of moving to the top right. Now else we'll take while variable, we are moving downside. So moving downside basically is we are checking if I is less than n, so it should not go beyond this, and then j should not go beyond this, below this. So j is 0, so we'll be checking if j is less than greater than equals to 0, and here we have to put answer we have to put in k and matrix of I j we are putting, and then we have to increase the variable k, because here also you have to increase. K plus plus, because we'll be placing element at here and then we'll be increasing k, so that next element can be placed here. If you don't increase, all the elements will be placed here. So at the last, what will be the element that will only display, so we have to increase. Here also have to increase k plus plus. Same case here also. And now we were here, we were moving downside. So in that case, let's say we are here. So if you want to move here, so what we have to do is, let's say here you want to move here. So what you have to do, you have to increase I and then you have to decrease j. So we have to increase I and decrease j. Here let's say we don't have element at this position, so we have to check downside. So in order to do this, we will be checking if I is less than n. If I is less than n, which means we have element at the down, so we have to increase I and then flag variable will set to 1, because after this we have to move up, upside right. So now let's say we came here. After moving here, we came here. So we don't have element left side bottom also, and we don't have element at the bottom, since I less than n will condition fail. So we have to, in this case we have to increase j. Else what we will doing is we will increase j and set the flag to 1. And basically this also will be like all the elements we have to add one by one element. We should keep adding. Control V. So at last we'll be having the answer. We have to return this answer. So let me run the code. So runtime error 8. So basically here we have to put +1, because we have to check next element, right? Let's say we are going top. So since we don't have element here, now we have to check j plus 1. We have element or no. So this is the case, and here also I think I plus 1. Since we'll be moving here downside, next we have to check if element there or no at the I plus 1 position. So we have to put I plus 1. Here also same thing, since we are moving down, so we have to check, let's say I we have here, so I should be increased and then j should be decreased. So we are checking I should be increased and j should be decreased. Now let's run. Yeah, all the test has processed. Now let's submit the code. All discoveries. So thank you guys for watching my video.